Hey everyone, I'm Brian from the Build It channel. In this video, I'm going to show you how I made a vacuum fluid extractor. The capacity of this system is about a half a gallon. Here's the first system I had. I had a quart mason jar and my vacuum pump that I'm going to use on the new one. A short length of PVC hose, and then basically an inline foot switch that controlled the motor operation. The vacuum pump you see pictured here is one that I've had for many years. The optional thing would be it's one I found on eBay, or you can find an old dorm refrigerator, take the compressor out of that and use it as a vacuum pump. Or this is a pump that I got out of an old water cooler they were scrapping, and I just put a SAE quarter-inch fitting on there to do refrigeration work, and that pump has run me for very many years. First thing I'm going to start on is make the cage to hold the jar. I have these rings already, so I'm just going to cut them to length so I can get about a 5 1/4 inch ID on the rings to support this. And then I have 3 vertical pieces that will come up to support it. So you'll see in a few minutes. How these round pieces are marked. So I'll start cutting this. Same thing for the other side. So you just got to form this back into a full circle and put a tack weld in it. Be done. Have the 2 rings complete. That's going to go around the jar. There's a little bit of slop on that. Okay, I'm going to cut this to 8 inches long. At 8. It's going to have a 1-inch foot. So I left the mark there for the foot. And there's going to be a hole to mount this down to the base. So I'll mark that while I'm here. It's 3/4, so it should be 3/8 the center. The center mark for the mounting hole. We're going to take the drill. This is a drill a hole, clearance hole for probably number 10 right there. I'm going to use the bulldozer die, make this bend. Just a little bit more to make it a 90. Looks good. Next one. Yeah, I have the 3 uprights done, and what I'm going to do is weld those equally spaced around this ring, like so. And then this bottom ring will come up, I believe it's about 2 inches or an inch from the bottom, somewhere in there, to hold the mason jar. The cage is all clamped up, ready to weld. I'm not going to show any of the welding, just show that I got it clamped up. Next thing you'll see that it's all welded together. I have the cage all welded together, and here's my half-gallon mason jar. It's in there, a little bit of play. That should support it, keep from falling over when you're working. I have a piece of solid vinyl that I'm going to use. It's a 3/4 inch piece of material that I'm going to mount all this to. But first I wanted to set everything in place to determine how big of a piece of wood or a piece of vinyl that I'm going to need for making this. So I got the cage for the jars in place, the pump is in place, the vacuum pump's in place. This will be the junction box for all electrical connections. And this flange is where I want to plan right now to have a handle come up out of that as a carrying handle. So those are the pieces, the major pieces for this project. I decided on making this piece of wood 11 by 16 inches, and that should fit everything with a little bit of room to spare. I have my base cut to size, and before I cut the base, I pre-marked the holes where I had things placed so that I can drill those holes. And I like the way it's setting, and I think I'm going to drill the holes out now for everything so I can continue on. I decided to use the original shock mounts under the motor, and the motor was mounted through the shock mounts to a piece of PVC, and this is vinyl, so I don't know how well vinyl is going to tap. Never tapped it before, so this will be a brand new experience for me. So let's see how that goes. Appears to be tapping fairly easy. It doesn't appear to be really gummy like I thought it would be. See how well this threads in. It tapped real easy, so that should go in fairly easy. Looks like it's going to work perfect. So I'm going to do the other 3 holes. I'll be ready to mount the motor onto the base. Have the 4 holes all tapped real easily into this final stock. Put the shock mounts in. Now set the pump on. Put the nuts in place. Vacuum pump's all mounted. It's good to go. Now to make the input and vacuum port on the top of the mason jar, just take a valve stem, metal valve stem, take the valve core out of both of them. Then I'll drill a hole, 2 holes in the cap so that I can install this metal valve stem, just regular car type valve stem, but metal. And then one of these will have a tube attached to it, so I won't have to drill down into here to epoxy in a pickup tube so it goes close to the bottom of the jar. For the pickup tube, I'm going to use this brass tubing. It's 9/32 inch OD, and I'm going to drill 9/32 inch up into here just a little ways, and then I'll cut this tube to the length I want, and then just put some epoxy around and stick it into this valve stem. Okay, I centered up this valve stem, and now I'm ready to drill the 9/32 inch hole for that pickup tube. I'm not going to drill it very deep, just enough to kind of hold that tube in with a little bit of epoxy. Drill down about 3/8 of an inch, which should be fine. I'm going to cut the inlet tube to approximately 8 inches long. That should reach almost to the bottom of the jar. Mark there. Get a tubing cutter, line it up on the cutting wheel. This isn't exact, it's just close to where it needs to be. Clean both pieces with acetone, get rid of any grease residue or anything that could be on there prior to use any adhesive. Let that dry just a little bit while I mix up some epoxy. Tube into the valve stem. I twist just a little bit to kind of work it into that hole. Feels like it's bottom now. Screw it in there, just let it set up and dry. Our next step is to bolt down the cage using 1032 screws and number 10 lock nuts. Don't have to worry about lock washers or anything. I don't think they'll come loose, but go around and tighten these up, and we'll get on to the next step. For the wiring, I'm going to bring everything into this 1900 box. The wires for the motor already come here and knock that out, and then the wire for the power cord and the switch will be here. I have a 12-foot long extension cord I'm going to cut off the end, cut this end off and put that in so you have a 12-foot long cord, and then there'll be a foot switch to activate the pump. So you just
put down, switch it on. First thing I'm going to knock out these pieces, these knockouts. I have 3 connectors I'll put on there. These 2 are going to be tight. I think I'm just going to put them on top of each other like this. Put the first wire in, strip it back far enough. I'll make this whole power cord, I guess. Let me cut this off and strip it. Okay, I got the power cord stripped back. And just strip these wires. Put them in first. Now I'll put the connector above. It's definitely not the right way to do things, but I think it'll work. This will be the connector for the foot switch. Well, I don't know which wires to strip back on this right yet. Just stick it in here for now. I need to find out which pair of wires would be the normally open set of contacts. So I'm just going to put this in temporarily for now. I'm going to need to put a bushing around this wire. This clamp's not really a hole. Well, that's all kind of tight, but I'll probably still put a bushing around it. And then these wires are going to go in the back of here, so I'm going to definitely need a bushing around that bundle of wires. So I found a piece of rubber, basically just a piece of fuel line, just to act as a cushion. Straighten these wires up the best I can. These wires through connector. And open up the connector. You can see it, but I need to open up this connector and try to form where all the wires are going to go, or screw down this box. Get the other screws started. I want to find the normally open side of this foot switch, so I assume that white is a common, and I figure look at the black, and black is a closed. Push the foot switch, it opens up, so that's normally closed. So then that makes the red must be the normally open. So push on the foot switch, I get connection. So I'm going to connect between the white and red, and the black is just going to get pushed back out of the way. Finish off the ground wires first, get them terminated, since they'll be all the way to the back. Ground screw. I don't know if you're gonna be able to see this. I'm gonna put the two wires together, bring them around into that threaded hole for the ground, chassis ground on the box. Wire for the motor, and then the wire coming in for power get tied together. That line coming in, I'll tie that to the white or common on the switch. Knot that together. And the red is the normally open side of the foot switch. Tie the red to the black going to the motor. I'll power up the motor. There's all the wiring. Plug it into the wall. See how it works. See if I got it right. Okay, we'll activate the foot switch. Let's activate the foot switch. Wiring in the box is done, so I can put the cover on. I want to focus a little bit of attention on these wires coming from the motor since they were loose. I'm going to put tie straps on so that they kind of stay in place. Less chance of getting anything to snatch on them and break them. A couple tie straps on it should hold them all in place. Should be good. I have my two holes marked for the valve stem. I marked them, they're 1.5 inches apart from each other, so I got the first one ready to drill. I want to need to drill the hole to 13/32. So I put a piece of tape over this step drill to kind of guide me when to stop drilling. Should be the size I need, which it is. Go and set up for the other side on the same process. Just lightly drilling because these caps are pretty thin. Ooh, that one's good. Now on these valve stems, what I'm going to do is I'm going to take this piece off that came with it, because this is for going into our rim, and I don't want that much material, so I'm I'm gonna take that off, and there's a lip in here, and we'll put an O-ring. That'll fill that. The O-ring I selected, I'll have to get that here in a minute. I wrote it down. I don't have it with me right this minute. But basically that O-ring will go down in that recessed area, and that should seal up around that lid. So we put, these nuts are kind of hard to get started if you go the one direction. It's like they're self-locking, but they're not. It's just a burr or whatever. Both of them give me the same problem, not wanting to start. So I turn the other direction, they usually start better. For the inlet tube, I did the same thing. I put the O-ring in there. Basically just slip this on, this washer on, install the nut like so, and then I'll tighten these nuts down a little bit. I'm not gonna do this right now, but I have the jar, and here's the cap with the as you can see, a pickup tube. I don't know if you can see it for sure. The pickup tube is very close to the bottom. And that will just sit in the cage. It's like that. The hose hook up, all I do is put this black, this fuel line, and it's 1/4 inch, and then just tie it to the top of there. And then I cut a piece about 6 foot long of a clear tubing. I like using clear tubing. That way you can see what you're vacuuming into your container. And if you see the clear tubing is coming into the side that has the rod that brings the fluid all the way to the bottom. That way you don't get any splashing up and getting into the intake into your pump, because you don't want any of the fluids to get into your pump. So that's why that has a high pickup there, and then that drops in there. And now you can use this hose. You can pull fluid out of the pan of your transmission through the dipstick hole. I've used this for bleeding brakes. As a one-person bleed brake, you just stick this over the bleeder and open it up and pull vacuum, and it pulls the fluid out. I've also used it for checking the bottom of my oil tank to make sure there's no water in the bottom. So I just tie this to the dipstick, keep it off the bottom of the tank about maybe 1/8 of an inch, tie it onto the dipstick, drop it all the way down to the bottom of the tank, run the pump, and get a sample of oil out of the tank, let it sit for a little bit, and watch for water settlement in the bottom of the jar. So this is a very, in my opinion, very useful tool. I used it before. You've seen the pictures of it, just the pieces. But I still need to make a handle for it. So I need to do that. So that'll be the rest of the video. We'll basically complete this with the handle. I made a handle for carrying it. I just took a piece of standard 1/2 inch pipe, an elbow. I was going to bend this, but I decided just to use standard pipe and a flange to mount this down. And just use more number 10 screws to hold this. Just going to loosely put 2 of them in there and show you see how the handle works. See if it picks it up level or what it's going to do. Okay, I got 2 of them in there. It works good. Now I got a handle to move it. For the foot switch, just took a magnet and mounted it to the front cover of this box, electric box, and then just take and wrap the cable around and convenient place to keep the foot switch. You're going to see I have the pickup tube and some hydraulic fluid and just connected to the inlet on the vacuum system, and you should be able to see the fluid coming into the bottom of the jar. It's getting ready to come in, starting to fill up the bottom of the jar. So I do a real short vacuum test, see how far this will pull down. 20 inches, pretty quick. It's going to be 20, just under 25. Somewhere in that neighborhood. Don't look like it's going to go much below 25 inches of vacuum. It's not bad.